States of matter. Matter is made of tiny particles separated by distances with nothing between the particles, which basically means the particles make up the mass of the substance, and the distance refers to taking up the space. Hence the definition, matter is anything that has mass and takes up space. The particles are always in motion, and the amount of space between the particles varies with temperature, volume, and pressure. Most solid materials have a specific type of geometric arrangement in which they form when cooled, giving them a definite shape and definite volume. The type of geometric arrangement formed by a solid is important. Chemical and physical properties of solids often can be attributed to the type of geometric arrangement that the solid forms. Solid particles are closely packed together, and even though the particles do not look like they're moving, the molecules are vibrating in place. The particles in a liquid move more freely than the particles in a solid. They have enough kinetic energy to slip out of that ordered arrangement of a solid. However, the particles in a liquid have not completely overcome the attractive forces between them. This causes the particles to cling together, giving liquid a definite volume but an indefinite shape. In gases, the particles are far apart and the attractive forces between the particles have been overcome. Therefore, the gases do not have a definite volume or shape. Gas particles can spread far apart or even contract to fill the container that they are in. Solids, liquids, and gases are the three familiar states of matter, but none of them is the most common state of matter in the universe. Scientists estimate that much of the matter in the universe is plasma. Plasma is matter consisting of positively and negatively charged particles with an overall charge being neutral because equal numbers of both charges are present. Stars, including the sun, contain matter that is in the plasma phase, and plasma exists where the temperature is extremely high. It is also found in lightning bolts, neon, and fluorescent tubes. The kinetic theory is an explanation of how particles and matter behave. To explain the behavior of particles, it is necessary to make some basic assumptions. The kinetic theory is as follows. Number one, all matter is composed of small particles such as atoms, molecules, and ions. Number two, these particles are in constant random motion. And number three, these particles are colliding with each other and the walls of their container. Try to visualize a room of ping pong balls. Imagine each ping pong ball is a particle that is in constant motion. By visualizing this will help visualize the kinetic theory, with these balls bouncing and colliding with each other in a room. You usually use temperature as a term to explain how hot or cold an object is. In science, temperature means the average kinetic energy of particles in a substance, or how fast the particles are moving. On average, molecules of frozen water at 0 degrees Celsius will move slower than molecules of water at 100 degrees Celsius. Therefore, water molecules at 0 degrees Celsius have lower average kinetic energy than the molecules at 100 degrees Celsius. Knowing that particles move faster and separate as temperature rises, this separation of particles results in an expansion of the entire object known as thermal expansion. Thermal expansion is an increase in the size of a substance when the temperature is increased. There are many examples in the world around you. For example, have you ever noticed the seams in a concrete driveway or sidewalk? A gap often is left between the sections to clearly separate them. These separation lines are called expansion joints. When concrete absorbs heat, it expands. Then when it cools, it contracts. If expansion joints are not used, the concrete will crack when the temperature changes. Normally, substances expand as the temperature rises because the particles move further apart. However, the one exception to this rule is water. Water molecules are unusual in that they have highly positive and negative areas. When water freezes, the water molecules orient themselves according to charge, and empty spaces occur in the structure. These empty spaces are larger in ice than in liquid water, so water expands when going from a liquid to a solid state. Solid ice is less dense than liquid water, and this is why ice floats on the top of lakes in the winter or on the top of your refreshing glass of water. Okay, it is time to show what you know.